Hello, everyone. Good morning, good afternoon, and good evening to all. Dear authors and invited guests, welcome to the technical session 3A. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the second World Conference on Information Systems for Business Management, ISBM 2023, Bangkok, Thailand. My name is Anisha, and I am the moderator of this session. This second edition of the conference is being organized in a hybrid mode. The physical event is organized in Bangkok, Thailand today, and the virtual event is being held through Zoom today and tomorrow, that is 7th and 8th September 2023. This series is organized in an extension to the ICT 4SD conference series. I hope you all will enjoy the knowledgeable and interactive sessions through the day. So in this session, we have 7 presentations, and each presenter will be given 12 minutes for the presentation, wherein the presenter has to finish their presentation in 10 minutes, and 2 minutes is allotted for the question and answers round. I will raise a gentle reminder on 8 minutes. And there is another request to all the participants to please stay connected with us till the closing of the session. And if you have any query or update, you can write it to me in the chat box. So just before we start the session, I would like to introduce you all to the chairs for the session. Our first session chair is Prashant Dhotre. Professor Prashant S. Dhotre has more than 17 years of teaching and research experience. Currently, he is working as a professor in the Department of Information Technology of MIT School of Engineering in MIT ADT University. His publication includes more than 25 papers in the international conference and journals. His research interests include algorithms, privacy, and Turing machine. Welcome to the session, sir. And now I will take the pleasure of inviting the other session chair, Dr. Kenakan Fanefam. Dr. Kenakan received his BBA degree in Information System in 2005 from Rajmangala University of Technology, Thanyaburi, Pantham, Thani, Thailand, and MBA degree in Business Administration in 2008 and DBA degree in Business Administration in 2008 from Pathum Thani University, Pathum Thani, Thailand. He is currently a lecturer at the Faculty of Business Administration and Information Technology, Rajmangala University of Technology, Taiwan, OK, Bangkok, Thailand. I welcome you both to the session, sir. So before we start with the session, would you like to say something?
Yeah, good afternoon from here. So thank you, Nisha, for this kind invitation, and we look for great presentation from all the authors. Good luck to everyone.
Okay, so now we'll move forward with the paper, and I would like to invite our first presenter, Archana Gulati, to present her paper on the title, A Relative Study of Neural Network and Fuzzy Logic Systems in Multilingual, Multi-Document Textual Summarization. So, dear author, you may please share your screen and start the presentation.
Yeah, good afternoon all. Is my screen visible?
Not yet.
Is it visible now?
Yes, ma'am, now it's visible.
Good afternoon, everyone. I'm Dr. Archana Gulati, and I would be presenting my paper, A Relative Study of Neural Network and Fuzzy Logic Systems in Multilingual, Multi-Document Textual Summarization. The flow of my presentation would be introduction, a short brief on the literature survey and the findings of the literature survey, and the gaps identified, which will lead to the problem statement and the objectives of my paper, and then the proposed methodology along with the experimental results and the performance analysis. And to the end, I would conclude my presentation. To introduce to all of you, text summarization basically is a process of creating shorter version of original text that contains important information. Now, where all this text summarization is applicable, where headlines of news articles is to be generated, when we need abstracts of technical papers, so where we want a gist of the entire article or news or any other maybe some important you could say some stories, we could use this kind of application which I'm trying to create. Now, the categories of text summarization are, it's based on the type of summary that is generated, where it is either extractive or abstractive summary. So now what does extractive summary mean is, we are like what we have in our Microsoft Word, where the important sentences are just highlighted in the document. So it just extracts the important sentences directly from the document, whereas abstractive summary needs a knowledge of the natural language. So we actually understand the entire document, and then from that, a gist is generated in a human-like language. So a lot of natural language processing rules are required to understand what is abstractive summary and generate it. So abstractive summarization is quite difficult as compared to extractive summarization. The other category of summarization is either single document or multi-document. Where single, it is a single text document which you need to summarize, or it could be multi-documents where from multiple textual documents you are summarizing the, you're generating the summary. And then we also have, depending upon the language. So like many people have worked on different languages. So it could be single language, like it could be English, Hindi, Kannada, Bengali, and Chinese languages. People have generated summaries, or it could be multilingual, where multiple languages have been considered and summarization systems for multiple languages have been created. Again, there are different approaches to summarization, where like based on what kind of parameters or features we are considering related to the text for generation of the summary. So what we have is textual methods, linguistic methods, and then people have also worked on the hybrid methods. So what does basically statistical method mean is, we are only considering the statistical features of the text. Statistical features means the sentences that will be extracted, where they are located in the document, the position of the sentence, how long is the sentence, which kind of words are frequently occurring in that sentence. So based on the statistics, basically the importance of the sentences is analyzed, and then whether to include that particular sentence in the summary or not is decided. Similarly, linguistic methods, where more emphasis is on the language or the semantics and the syntax and the semantics of the language. So basically the meaning of the sentences are tried to understood, we try to understand them, and then based on that we try to extract important sentences. So an example of a feature like the semantic similarity or thematic based words, so these lead to linguistic based methods for text summarization. And the third approach is a hybrid approach, where we try to integrate the best of both the kinds of features, that is statistical and linguistic, and then we try to improvise the accuracy of our summarization method. So I'm trying to work basically on the hybrid method, where I'm combining the statistical and the linguistic methods. So I've gone through a lot of papers where people have worked on single document, multi-document. Okay, people have worked on in single languages, mono languages like English, there's Chinese, there's Kannada, Bengali. Even people have worked on multiple languages. There's a very less work on abstractive, whereas more work has been done on extractive summarization. Now, based on the findings of the literature survey, what I have identified is, most of the systems that were developed were for single document and multiple languages. Even though there are summarization systems generated for multi-document, but most of the systems were for English language. So most of the work has been done for English language, because a lot of ontology and a lot of background knowledge is available for English language. So a lot of data sets are available. Okay, very few systems are there which emphasize more on linguistic features and on the other languages. Why? Because the background knowledge is not available for the other languages, like say Hindi, Marathi, the Indian languages which I'm talking about. So a lot of background knowledge is needed to achieve good compression with good quality summary. And also we need, since we are talking about multi-document summarization, there's another concern, which is minimizing the redundancy. So when you're picking up sentences from different documents, you need to also take care that the similar sentences are not repeated again in the final summary. So minimizing the redundancy is another challenge. So and further achieving abstractive summarization for various languages is an issue. Abstractive summarization requires a lot of ontology, background knowledge. The natural language processing rules need to be generated to actually generate the summary in human-like language. So that is a very tedious task. So these were the findings from the literature survey. So based on that, the problem statement that I have framed is a multilingual hybrid text summarization system which is proposed that can generate extractive summaries for multiple documents. So I'm working on two languages basically, two Indian languages, I mean, which are common in India, that is English and Hindi, and applying a hybrid approach where I'm combining both statistical. I've actually chosen few features from the statistical approach and from the linguistic approach, and I've combined them to achieve a better precision in my summarization method. And also I'm working on multiple documents. The objectives of my proposed methodology is to create an extraction-based summarization system, to develop a system that generates summaries from multiple documents, to advocate a combination of varying features, that is statistical and linguistic, to improve the accuracy of summarization. Then I'm applying two machine learning algorithms, which I'm comparing basically, that is fuzzy logic, and I'm applying neural networks. And I'm applying these to two language text documents, that is Hindi and English. And then I'm doing a comparative analysis of the summaries generated by using the two algorithms to give the conclusion that fuzzy logic systems work best in my case. The proposed methodology can be shown in the form of this flowchart, where what I'm doing is, since it is a multi-document summarization, I'm picking up the different documents. I'm first pre-processing those documents. After pre-processing, the next step that is done is feature extraction and score generation for individual documents separately. After that, after the feature extraction and the score generation, the sentences would be ranked depending upon which algorithm I'm applying. So both the algorithms have been applied separately, and then the sentences have been ranked based on either neural network or fuzzy logic system. And then based on that, the sentences which have been highly ranked, a threshold has been decided, and then those sentences have been considered in the summary. So this process has been repeated for every document, and then the summaries generated for individual documents have been combined together. They have been concatenated to form a meta document. And then I'm applying the process again. I'm reapplying the feature extraction and score calculation for the meta document, and I'm performing the sentence ranking for the meta document, and then the final extractive summary is generated. I've also tried to apply translation, where what I'm doing is, it's like cross language. I've just used Google Translator to just convert the English language summary into Hindi and the Hindi language summary into English. So if the user wants the summary in a particular language, he can also, I mean, I have just added the API, and I can just translate the summary from Hindi and English language to the other language as per the user's requirements. So the proposed method one, which uses fuzzy logic systems, what we are doing is basically the feature extract, the document that I'm giving as input, each sentence would be analyzed, features would be extracted, and to each sentence scores would be given. Each feature would be first scored, and then based on that, the entire sentence would be scored. The inputs would be given to the fuzzy logic system. The fuzzy fire is going to convert the crisp values into fuzzy values. Then the inference engine, I have defined certain rules in the fuzzy rule base. So different if then else rules have been created to decide upon like which particular feature is given how much importance. Like if it is a sentence position, if it is the sentence length, if it is thematic feature, which particular feature has to be given how much importance. Based on that, I have designed the fuzzy rules, and then applying those fuzzy rules, the decision has been taken, like the importance of the like which sentences need to be included or not included in the summary. So that sentence ranking and extraction is done, and the final summary is generated. Similar way, the other method, the proposed method 2 is neural networks, where again the features which are extracted and the score that is generated, it is given as input to the neurons. So each feature is one input neuron. Then basically the logic has been applied. I mean, I've used error backpropagation algorithm, where I'm trying to minimize the error. So until I do not get the error as 0.01, that many epochs I'm running the algorithm. And then at a stage where around I needed 300 epochs, where after 300 epochs I was able to generate a sensible summary for my system. So after the sentence selection, the summary is generated. So these are the two basic proposed methods, fuzzy logic and neural network systems. Now in pre-processing, basically what I'm doing is the first step, that is I'm segmenting the sentences. So I've just given an example from the news articles for English as well as Hindi. So in sentence segmentation, wherever I get a full stop where the sentence completes, I'm breaking down those sentences into parts. Similar way, in Hindi language, we normally have those bars which indicate the completion of the sentence. So I just traverse my text through, I traverse the text, and wherever I find that bar, I just separate out the sentences. So I am segmenting the text. After segmentation, the next step that is done is tokenization, where I've shown the example of English as well as Hindi. I try to remove out all the special characters like commas, full stops, exclamations. If anything of such characters are there, I'm trying to remove them out, because these will just increase my the effort in summarization. These kind of these symbols are not required basically for summarization, so I'm trying to reduce my effort while summarization. So I'm removing those tokens. Then I'm removing the stop words as well. So the stop words are nothing but some in the grammar you basically need those words, but even if they are removed for my summarization system, they will not play that for feature extraction. Those particular words will not play a major role. So the words like and, to, and the, these kinds of words which are called as stop words, they are which are available in the English dictionary, have been removed. After that, what I do is stemming. So stemming basically reduces the word to its root word. So there are in the previous document, if you could see, there are words like higher, achieved. So after stemming, I achieve. If you can see the output, I have see Lydia, Sebastian, achieve. So I'm coming to the root word of the inflected words basically, because the inflected words may not be in the dictionary. I would need the root words to understand the context of the word, how it has been used in the document. So I am achieving the stem words, the root words of every inflected word, both in English and Hindi. And in Hindi, I have also tried to design my own stemmer based on the rules of Porter stemmer. So the Porter stemmer has been designed for English document. So similarly, we have tried to design a stemmer for Hindi documents, for Hindi language.
Excuse me, ma'am.
Yeah.
Sorry for the interruption, but could you please conclude your presentation?
Sorry, I have to complete it in 2 minutes, right?
Yes, yes.
Yeah, ma'am. I'll just find. The next step is feature extraction, where I have used a hybrid of 11 features, that is average term frequency, inverse term frequency, which basically tells me how important a particular word is in the, how many times it has occurred in the document, and how important it is in the document. So this particular feature is for that. Then is the length of the sentence. So length of the sentence, basically very short sentences and very long sentences could have redundant information. So just to decide on the important sentences, I need to decide upon a length, the threshold of the length. So I have used this formula for length of the sentence. Then what I have is the location. Normally the sentences that occur at the initial part of the document and at the concluding part have the convey the most of the relevant information, and the certain sentences within the body of the document would give you some information. So I need to decide the threshold, that how many sentences from top and from the bottom and from the body of the document needs to be selected. So for that, the next feature. Then I am comparing the similarity between sentences. This is just word to word similarity. So if the number of major overlap in the words will decide how similar the two sentences are. So this is plain statistical feature. Then since I'm talking about news articles, if it is politics, my domains were politics, sports. So there could be numerical data also, like it could be in terms of dollars, it could be in terms of scores. So if a sentence has such kind of figures, then that sentence again is relevant. So numerical data also plays an important role. Then I have title overlap. So if your sentence is somewhere having some words overlapping with your title, so again, I'm giving a little more weightage to those kinds of sentences. Then subject, object, word, and subject, verb, object. So this is a qualifier where normally English language, it follows a particular pattern, that is SVO, or your Hindi language follows a SOV pattern, right? So if your sentence is following that grammatical pattern, so I'll traverse the entire sentence, I'll identify the subject, I will identify the object, I'll identify the word. So if my sentence qualifies all these three parts of speech, then I say the sentence is well qualified, then I give it a grade 1, else I give it a grade 0. Subject similarity is if somewhere in the title I have a subject which I'm talking about, and if any sentence has a subject, in any sentence I have relevance to that subject, I give that particular sentence a additional weightage. So, and then I have clue phrases, where clue phrases are what, like suppose in certain documents we have words like significantly, this has been observed, while concluding, good morning, or I mean, these kind of significant clue phrases which tell me, yeah, something important is going to be highlighted in the further coming in the document or in the sentence. So in that case, these clue phrases would be, I mean, the sentences with these clue phrases would be given importance. So I've identified 207 such clue phrases. I've made a database of it, and then I'm just checking my document text through these clue phrases. And if they are there in the text, then I am giving them a higher weightage. Thematic words are most frequently occurring words in a particular domain. Like if it is a sports domain, if it is politics domain. So there are certain words which are frequently occurring in those domains. So I have made a database of those frequently words, and I just compare. So if those words are occurring in that sentence, I give that sentence a higher priority. Then is a lexical similarity, which is a linguistic feature where what I'm trying to do is, first I'm finding out the lexical similarity between two words, and then I'm finding out the lexical similarity between two sentences. Basically, in lexical similarity, what I'm trying to do is I'm trying to identify the lowest common subsummer. That is the ancestor of two common words. Because say for example, if it is say goose and kangaroo, okay, if they both they have a common ancestor, mammal. Again, mammal and you could say amphibian, they have a common ancestor, animal. So I need to reach to the root of the family, and then suppose then again somewhere kangaroo and moose are related to one another. So if these words are coming in my sentences, I need to understand how relevant these two words are. Similarly, based on the relevance of every two word, I'm trying to identify the relevance of two sentences. So this formula has been created to understand the lexical similarity between two sentences. Then I'm applying the fuzzy logic, and the neural networks as already explained in the diagram. So I apply, after feature extraction, I'm applying either fuzzy logic or neural networks, and then the final summary is generated. I'm trying to, then the performance analysis is done on basis of precision, recall, and EBSCO, where precision is the number of correct sentences number of correct sentences extracted divided by the total number of sentences extracted in the summary. Recall is the number of correct sentences extracted divided by the number of sentences that should have been extracted, which are there in the standard summaries. So which should have been in the summary, which have not been generated by my system. And then F-score gives me an average of the precision and recall. It is the harmonic mean of precision and recall. So these are the screenshots of the steps that I have carried out, the experimental results basically, the feature extraction step, the summary generation step, and then how the performance analysis is represented. And then the evaluation of the Hindi text summarization using fuzzy logic, that is the hybrid feature, the 11 feature. I worked on different data sets. For Hindi, I have generated my own data set because data sets are not available for Hindi language, as well as the library, WordNet library created by IIT is not that efficient as compared to the one which is there for English. So I could get better results for English as compared to Hindi. And then after the comparative analysis, we can come to a conclusion that from the above experimentations, it is concluded that for multi-document text summarization, using basic fuzzy logic systems gave more accurate results as compared to neural networks. It is observed that the results are good on for few data sets, whereas low on few others. But on an average, there's an improvement by 15% precision in Hindi and 20% for English using fuzzy logic systems for the proposed application. The system performance has surely improved by addition of the semantic feature, where the Hindi corpus, if I consider, I'm getting for fuzzy 58.46 and precision for neural is 42.08, whereas in English it is 65.29 and for neural it is 44.15. So that is what is my conclusion, that I have achieved better summarization for fuzzy logic systems, using fuzzy logic systems for both English and Hindi. These are the references. Thank you.
Okay, so does anyone has any questions? No question. Professor, so you have some question to ask her?
Ms. Archana, can you hear me?
Yeah, I'm hearing you.
Yeah, can you just go to your slide number 7?
Yes, sir.
So based on your presentation, linguistic features, what do you mean by linguistic features?
So is my presentation visible?
No, that's okay. Now it's visible.
Okay, I'll go to the 7th slide. Sorry. Yeah. Yes, sir.
So my question is, what is linguistic feature?
Few systems that emphasize more on linguistic features. Sir, as I said, the 11th feature which I was talking about, the lexical similarity, where actually we are talking about the meaning of the sentences. So it's not just like word to word comparison, but in linguistic feature like lexical or semantic similarity, I try to understand the meaning of the words, and then based on the meaning of the words, I try to compare two sentences. In plain word to word, what happens is we just check if similar words are there. So the more number of similar words are matching in two sentences, we say that they are similar. But it is not that always. There are certain linguistic features like the semantic similarity, like the last feature which I said. We need to go to the trace back the ontology. Like as I said, I gave you an example of say cat and dog. Cat and dog could be in the community of carnivores. Carnivores could be in the community of mammal. So I trace back through the ontology, and then somewhere if its predecessor is matching, in that case I say those two words are somewhere relevant to each other. The concepts are relevant to one another. So when we do these things, we try to understand the better meaning of the sentences or the text basically.
How the features are stored?
How the features are
How the features are stored in the memory?
so features the scores of the features would be stored. So what will I do is every sentence, for every word I'm going to extract the feature score, and basically the scores are stored as vectors.
Okay, thank you for your answers.
Thank you, sir.
Okay, so thank you very much. Okay, so we have limit time, so please turn to the next presenter.
Thank you.
Thank you.
Thank you so much, Archana ma'am, for the presentation. And now we'll be moving forward to our next presenter. And I would like to invite Ritu Srivastava to present her paper on the title Framework for the Adoption of Digital Transformation, a study on the banking and financial services industry in India. So dear presenter, you may please share your screen and start the presentation.
Thank you. Is my screen visible?
Yes, it's visible.
Thank you so much. So I have a background in management education, and the theme of this study is Framework for Adoption of Digital Transformation, which is a study on banking and financial services industry in India. So these are the industry reports that we have been reading. ICT has become a big driver of mobile payment growth in consumer spending apps. And consumers, around 64% of consumers have had used one or more fintech platforms. And that's almost a 50% growth between 2017 and 19. Specifically, we saw in COVID-19, those in companies who were the first ones to adopt digital technologies they reported very effective responses in terms of sales revenues. And then, of course, we also found published reports saying that workforce is an essential ingredient of digital transformation strategy. And then, of course, there's always a challenge to organizations how to facilitate this digital transformation. And specifically, we chose financial organizations and we did a literature review on this phenomena of digital transformation there. So, of course, in terms of we were focusing on the role of employees and executives in the digital transformation strategy of financial organizations. So we found that even employees or executives, they said that, I mean, at the CEO level, it was a top priority. In 2020, we are talking about those reports. And 40% of all technology spending was actually going towards the digital transformation of the entire organization. And revolution in financial technologies and change in consumer preferences also led to a lot of companies in BFSI sector, which is banking and financial services sector, to adopt digital transformation. And this research is done by me and my colleagues and my research scholar. So my research scholar had been working with the Central Bank of India, and he still is working, and he has a close contact with these banks and their employees, and he's got a vast experience of 22 years. And he found that yes, there is this challenge of actually successfully doing digital transformations in these companies, and especially for financial organizations. And though financial organizations have adopted technologies, but there are certain important issues, especially the linkage between employees orientation and successful strategy transformation. That aspect he finds, we also discovered that needs more research. And of course, this is a very simple view of the literature review that has been done. So there was the section on the concept of digital transformation, fintech organizations. And then, of course, what are the drivers of effective digital transformation? What are the change management challenges? What is driving employee engagement and employee performance during this journey? And then, of course, because this research was done in 2021 and 2022, still we wanted to understand how COVID-19 had impacted, or it presented an opportunity for digital transformation. So looking at the research problem, objectives were framed. So financial, we were doing this in the Indian markets, and there are plenty of still banks and financial institutions who were unaware of their readiness to adopt. They wanted to adopt, but they were not aware of their readiness to adopt, and they were not aware of what are the components that will drive the organization's readiness for successful adoption. So it led to the associated objective that whether organizational readiness, OR is standing for organizational readiness, is significantly impacting successful adoption of digital transformation. The second is, of course, employee readiness, which also impacts the digital transformation exercise. And so what are those critical components of the employee readiness? Because we know BFSI is a service industry, and the human aspect of it is there. And so, what are the components which can lead to more employee readiness for successful DX? So these were, so for this particular paper, we've taken a part of that study, and we've taken two dependent variables. which are organizational readiness and employee readiness. And if we look at organizational readiness, these are the some variables that have been taken. So organizational readiness is driven by leadership and management readiness, then governance readiness. Of course, employee readiness is also a part of it. Organizational approach towards this journey of digital transformation. And then, of course, we are also looking at the cost part of this exercise. So organizational readiness is determined by these variables. And then employee readiness is determined by how much the employee thinks he's going to be more productive after he participates in this digital transformation, how much he thinks his quality of output will increase, how readily he will be getting the required data and information. Of course, his approach, his attitude is again a very, very important factor. Then, of course, his skill set. So if the skill set is not appropriate, he may not be ready actually to participate. And then, of course, the performance matrix of the overall unit. And then, of course, sometimes because of COVID, also employees understood that yes, digital technologies have to be embraced. Then, of course, this is the table which talks about each of these variables and the associated hypothesis and the questions that we made. So leadership and management readiness had 3 items in the questionnaire, and this was the associated hypothesis. These are all alternate hypotheses. And then, of course, in governance readiness, again, there were only 2 questions: employee readiness, 4 questions, organizational approach, overall to the culture of the organization. This is related to a little bit of organizational culture and what is their approach towards doing new things. And then, of course, if whatever, in terms of the transformation, is the organization capable of absorbing that cost and effectively looking at the return on the investment, anticipated return on investment. Then if you look at the employee productivity, this is for the other independent variable, which is the employee readiness. So in terms of employee productivity, output quality, usage of data and information, as already discussed. So we had 2 questions. Output quality, we had just 1 question. We had taken initially 2 more questions, but they could not pass the test of reliability. Usage of data and information, 2 questions. Employee's own approach. And sometimes, it is driven by the fact that, digital technologies can be tricky and they might lead to things which employees cannot handle themselves, and skill sets, performance metrics, and continuity during pandemic situation. Specifically, people felt that, when we adopt digital transformation, does it lead to more work-life balance, and does it lead to continuity of job, because business is continuing owing to these digital transformations and digital technologies. And then we had the last hypothesis number 13, in which both these 2 variables were the association and the degree of association was measured. And this is a brief overview of the respondents' profile. So you can see.
Ma'am, I'm so sorry for interrupting you, but you have only 2 minutes, so kindly conclude the presentation.
Thank you for this. I'll just close quickly. So the idea was to include people from all levels. And then BFSI is a sector in which there are a lot of government-run banks, private banks, NBFCs, even responses were taken from the central bank. So this was a major, and then urban cooperative banks. This was a big exercise in getting accurate data. And so we had 473 respondents, and it took almost 7-8 months to get this data. And then, of course, they were also people working in different departments. Mostly, I think you can see there's a big spike in terms of overall monitoring of the organization's functions. So this is at the branch level or at a department head level. So these were the respondents' functional roles. And I'll just quickly move towards, just give me a minute, to my results. Of course, we were able to prove all the hypotheses. Just a minute. I'm just going to come to my final SEM model so that I can show what we finally did. So we were able to get these R squares. If you look at the employee readiness, it was very good value that we got, 0.931. As far as organizational readiness, it was just 0.676, but quite, I mean, a loading which, a coefficient of determination which we can consider for the study. And as far as the validity and reliability, as I told you, we had to drop few questions because the data was not reliable. Otherwise, we have checked everything, and as per the acceptable values, only reported them. So multicollinearity, and then all the hypotheses finally were tested using one-tailed t-test, where rho value was less than 0.01. And then t statistic value was greater than that. And in fact, convergent validities with average variance extracted values were also above 0.50. So we were able to reject all the null hypotheses and accept all the alternative hypothesis. And that is the end of the this particular paper. And of course, it just kind of the utility of this study is that it tells the organization how to go ahead with, how to prepare themselves, how to be more ready in terms of adopting digital transformation, and what all employees, how employee readiness can also be built up for this transformation journey. So that is it from my end, and there's a lot of scope here. Thank you very much. I'm open for questions now.
Thank you, Ritu, for your presentation.
Yes, sir.
Can you go to that slide where you have statistics about the participants in terms of survey?
Sure. Which one, sir?
Maybe the previous one.
This one?
Yeah. So how do you identify the respondents?
Okay, sir. I'll surely share, sir. I had very less role to play here. My doctoral scholar is working with the RBI. So he is working with the central bank. And my relatives and my friends and colleagues, they were working with different banks. And some of my students are also working with banks. So we tried to use this. Also, we floated our questionnaire on LinkedIn. We tried to contact people through LinkedIn. Because people who, I mean, when people were asked to fill in, and we realized randomly asking people was not giving us accurate data. So we decided to then pursue people across. So we had these stratified kind of sampling design ready. We were wanting to get respondents from each of these types of organization. So, yeah.
Okay, but how do you trust the responses from all the respondents? Because when you share the feedback form, maybe through LinkedIn or your personal connect, the first thing is that if we have questions more than 10, generally they ignore, or
yes,
they feel just like they want to feel. So how do you ensure that the responses are appropriate and correct to your research?
I think partly we relied on the reliability measures statistical reliability measures. And if there were outliers specifically, like I said, 2-3 items we had to drop because they were not reliable as per the statistical tests. But this biasness, this problem, sir, is still there. I can't completely say that it will be eradicated. But we tried to give them some time. We were not in a hurry, and we went to the right people, people who are actually at the level where they implement the strategy. They are partners in the process. So we could trust that they had the knowledge and the experience. Whether they have given the right responses is something, yes, which we can't totally eradicate, that biasness, prejudice, or casualness. Yes.
Okay, thank you for your presentation.
Thank you, sir.
Okay, so let me might give some advice to improve your next research. So you have to choose your IOCs because this is a survey research and you didn't use the mixed method. So that's why this is the weak point for you. So you have to in-depth interview like parallels or the first for the first step before you are gathering data, because to reduce bias of data, because this is only survey research. So that's why you have to reproduce your paper for further research as well. And so you have to describe more and more in your research implication and research contribution.
Yes.
But you didn't mention about you just mentioned about academic benefits, but you didn't describe, and you have to make more clear about what is exactly to your practicals or implementing contributions. For example, like you can use your research backup to set up a policy.
Yes, sir.
For
Yes.
example, so you have to make more clear in your next research. Okay, thank you.
Sir, just a minute. I thank you so much for your advice. And maybe, we have had interviews, in fact, with people while we were making the questionnaire. We can reproduce them in the thesis. That's a very good, thank you so much. And as far as the policy implications, yes, that is what we are going to do once all the variables are captured. That will be the output of the research. Thank you so much, sir.
Okay. So please turn to the next presenter, Anisha.
Okay, sir.
Okay.
Now, I would like to call our next presenter, Tivalade Odu, to present her paper on multi-instance contingent fusion for the verification of infant fingerprints. Ma'am, you may start with the presentation.
It seems she's not present in the session, so we can move forward to our next presenter.
Okay, ma'am.
Please skip to the next one.
Yes, sir.
Thank you.
I would like to call our next presenter, Deep Rohit, to present his paper on the topic potato leaf disease detection using convolutional neural network. Sir, you may start with the presentation. Sir, are you there?
Soumya, he is not also present in the session, so we can move forward.
Okay, ma'am. So I would like to call our next presenter, Mayumi J. Okno. So, ma'am, she will be presenting risk management for artificial general intelligence by limited liability companies. Ma'am, you may start with your presentation.
Thank you, Asha. Could you please wait for a while? I'll share my screen.
Yes, ma'am, now you can.
Anisha, can you see my screen? Is the slide show?
Yeah.
Yes, ma'am.
Yes,
Thank
it's
you very
visible.
much. Thank you. Thank you. Well, let me start. Good afternoon, everyone. I'm Mayumi Okuno. Today, I will talk about the necessity for risk management for artificial general intelligence by limited liability companies. This work is collaboration with Hiroshi Okuno. Here is a list of important terms used in today's presentation. The EU AI Act, unveiled by the European Parliament in 2021, set a visionary path for AI's future, accentuating fair, transparent, and accountable AI systems and the harmonious integration of AI into society. In 2021, EU AI Act was proposed to control AI systems based upon 4 categories of risk-based approach as shown in the triangle diagram. However, with the creation of the GPAIS in 2022, the situation regarding risk management has changed dramatically. The rise of generative AI and chatbots, along with the establishment of GPAIS as foundational models, has greatly accelerated the journey toward achieving artificial general intelligence. 4 categories were not enough for risk management of GPAIS. GPAIS as a software generates multiple applications, and the magnitude of risk differs for each application. Therefore, instead of using GPAIS as the basis, it has become necessary to control the risk for each application from A to D, as shown in gray in the chart. In other words, instead of restricting the GPAIS itself by rule, only the gray application C, this one, in the chart, which falls under unacceptable risk, should be restricted by rule. More importantly, the risk posed by application C should be confined only to application C and not affect applications A, B, and D. Therefore, we need to consider how the risk of all AGIs, including GPAIS, should be controlled. What we propose is risk management by a series limited liability company called a series LLC. Let me explain the LLC, limited liability companies, before the series LLC. Limited liability companies are rather new business entities, and the 2 main statutes, ULLCA and DLLCA, mentioned in this slide. Since members of an LLC are limited liability ones, like corporations, an LLC provides a vertical liability shield. Vertical liability shield. In other words, it processes it protects members from the company's debts. We think that an LLC is an essential structure for initial AGI risk management. This slide delves into the strategies of managing AGI-related risks using LLC structures. Emphasizing the efficiency and cost-effectiveness of the series LLC approach. When it comes to AGI risk management, envision each AGI application as a curve, as shown in our diagram. Let's focus on method 1, which is single LLC ownership. Method 1, one LLC owns all applications, occurs as shown in our diagram. If one application faces significant liabilities, it can jeopardize all applications within the LLC. This could lead to halting certain businesses or even the entire operation. To avoid that risk, method 2 is proposed. Method 2, each AGI application or franchise operates under its own individual LLC. Method 2 isolates liabilities. A claim against LLC A will not impact LLC B or C. Safeguarding the assets of unaffected LLCs. However, method 2 increased overhead as managing multiple independent LLCs can be costly. A streamlined solution to method 2's cost issue. To solve this cost problem, we propose to use series LLC, which is shown as method 3. This slide presents a concise overview of series LLCs, emphasizing their structures, advantages, and relevant in today's diverse business landscape. Series LLC acts as the master structure capable of creating multiple series. Individual series operate under the main series LLC, each with distinct assets and liabilities, designed to function as distinct business entities within the overarching series LLC. Method 3 enables a single business entity to run multiple unique business units. Method 3 provides a flexible structure for managing a variety of ventures of assets. Method
Sorry,
3
ma'am, for the interruption.
Okay, 2 minutes left.
Ma'am, you have 2 minutes left.
Okay.
Kindly sum up quickly and come to the conclusion.
I will, thank you. Method 3 provides two types of liability shields, horizontal liability shield and vertical liability shield. Horizontal liability shield ensures that the assets and liabilities of one series do not impact others within the same series LLC. Vertical liability shield protects the overarching series LLC from the liability of its individual series. Given the inherent advantage of both vertical and horizontal liability shields, adopting series LLC structures can be highly beneficial for managing varied AGI projects, ensuring risk minimization and operational flexibility. This is the summary. A proposal of using LLCs for AGI will provide a road to protect AGI businesses and developers from the risk incurred by the EU AI Act. The key concepts of our proposal are vertical and horizontal liability shields. Those three LLC frameworks are still maturing. The advantage lies in their compatibility with existing legal systems. This is a take-home message. To cope with the potential risks of AGI, we propose at the risk management to adopt LLCs, in particular series LLCs as a business entity for AGI by utilizing vertical and horizontal liability shields provided by LLCs. Thank you very much for your attention. Can I have any question?
Okay, thank you for your presentation.
Very much.
Okuno.
Okay, it's my family name, yes.
Okay, so so you study in you work in Tokodai University?
Toyo University.
Tokodai.
Toyo.
Oh, Toyo. Okay.
Yes.
Okay, so your presentation was very good, but so I'm not clear about your research instrument. So we guess your research is a quality research. Right? Is it quality research?
Quality research.
Okay, not quantitative. It's qualitative research.
It's a kind of, yes. Thank you.
Okay, so so doesn't it question to ask her or give some suggestion for her research? So for my idea, it's a tough for me. So so I think this is a tough to me, and I have no doubt because this is not an it's a qualitative, it's not quantitative research.
Sorry, it's not quantitative, qualitative research.
Yeah, it's qualitative research.
So sorry for that. Thank you. Qualitative research, yes.
Yeah, I know. I guess that. Okay, so please turn to the next presentation, and thank you for your presentation, Okuno.
Thank you very much, Doctor. Thank you.
Yeah, thank you, Mayumi, for your presentation.
Thank you, Doctor.
Yeah, I have no questions for you.
Okay, thank you very much.
Okay, so please turn to the next presenter, Anisha. Thank you.
Thank you so much.
Thank you very much, dear author.
Thank you.
Now, I would like to call upon our next presenter, Sabiri Goswami, to present a paper on sentiment analysis using fuzzy model. Ma'am, are you there?
Yes, thank you.
Okay, ma'am, you can share your screen, please.
Good afternoon, everyone. Good afternoon, sir. I'll just share my
Good afternoon. You can start your presentation.
I'm Shabiri Goswami, and my topic for presentation is sentiment analysis using a fuzzy model. So, natural language processing and sentiment analysis are both required in my research work. So it is a useful tool in knowledge management, and sentiment analysis is an application to determine people's opinion on any topic. So the main goal of this model is to analyze emotions by combining the advantages of natural language toolkit and fuzzy logic. So here it is used as a text processing tool mainly for decision support systems. Now, it is very important to understand how people feel about any particular product or any situation, to analyze the risk and assess the outcome. So for this research, several models and systems have already been created. Different methods like rule-oriented machine learning and several kinds of devices have been already researched. But the uncertainty and approximation still remain after a lot of analysis, and sometimes the negation contents are also overlooked. In order to make it easier to extract sentiments or assess the risks, we have developed a fuzzy sentiment analysis model, and this is basically used to handle vague expressions and mostly which are context dependent sentiments and also ambiguous sentiment cues. This is used to assess, we also assess the advantages and limitations and try to enhance the accuracy of the sentiment analysis models. This is done by using fuzzy logic techniques to capture subtle variations and some mixed emotions in different kinds of texts. The modules that we use for this work are data processing, sentiment value calculation using some equation, and finally the fuzzy inference module, which has some inference rules to separate or classify our sentiments. We have used speaking about the dataset, we have used the Python IMDb movie reviews dataset, which is available on Python. And it contains 1,000 positive and 1,000 negative sentiment reviews, as we can see from the graph visually. And we have also tried to find the subjectivity and polarity of the text and shown it graphically. So the first task, which is data processing and cleaning, involves removing hashtags, usernames, URL, emoticons. If you are using the if you are using text from social media or the internet, we are doing data analysis, tokenization, case conversion, spelling correction, stoppers removal. Now there are a few challenges which we have faced while using NLTK. So mainly, I'll make it short. There are some context-specific meanings which was not analyzed properly, and so all the inputs are treated in general context, and then we have negations like not, never. So it is very important to handle such negation patterns, and we also have sarcastic texts, which is required to analyze more accurately. Now, for calculating the sentiment scores, we already have some formula, which is the summation for positive score, which is the score of all the positive, which is the score of the positive sentiment of a text, which is the summation of the positive sentiment words divided by the total number of words, and the negative score is the summation of the negative sentiment words divided by the total number of words. So this is a basic formula, but we have considered the negation words like not, no, don't, can't, and so that the polarity of the word can be inverted. Now, this formula has been improvised using improvised as follows. So this is an equation which we have used where PW is the summation of the positive sentiment words and the summation of NW is the summation of negative sentiment words, and NW is the total negation before the negative words. So here we can see that we have to when we find the positive score, we have to subtract the negative, the negation for the positive words. and W is the total number of words. So here the equation is summation of the positive sentiment words plus the negative sentiment words minus the negation minus the positive words which has negation words. Like for example, okay, I'll come to the example later. So after we do this, we have to normalize the scores. And this is the equation for normalizing the score, which can be, this is the purpose of normalization is to be able to use it in the fuzzy inference model. Now this is the fuzzy inference model, where the input is the sentiment scores. We first fuzzify the scores, then we have the rules, fuzzy rules, and then we defuzzify and get the crisp values. This is just a representation of the fuzzy set. And this is the equation that we are following for fuzzification. Now, these are the fuzzy inference rules. The input that we are, the output that we are getting from the sentiment scores can be either low, medium, or high. So accordingly, we have set these rules where if the positive sentiment is low and the negative sentiment is low, then the sentiment has to be neutral. If the positive is high and negative is high, then also the sentiment has to be neutral. Same way, positive medium, negative medium, sentiment is neutral. Now, if the positive is high and the negative is low, if the positive is high and the negative is medium, then the sentiment will be positive. And if the positive is low and the negative sentiment is high, either high or medium, we classify the sentiment as negative. Now, here is an example. So here, after defuzzifying, we have got this graph. So for a sample text like, I love this product, it's amazing. So here I have not taken the negation, but if we take a negation like, I love this product, it's amazing, it's not bad, just for example. So it will calculate all the scores for the love this product and amazing, and it will if the word is negative like bad, if it finds a negation word which is not before bad, it takes it as a positive word. And so here the positive words which is calculated as love 1 plus 1 plus 1. So not bad is being calculated as 1 for positive, calculated as a positive word. So this is the result that is obtained from this sentiment, the graph which is obtained, as we can see. Now the algorithm is as follows. So first, as I've already explained, the input data set is pre-processed. We load the model and the tokenizer to tokenize the pre-processed text. The sentiment scores of the text are then calculated using negation rules. The scores which are obtained are modified to fuzzy sentiment values by using fuzzy logic model. The output sentiment here is obtained, for now it is obtained as positive, negative, and neutral, but we are also trying to obtain it as, we can also obtain it as very positive, neutral, very negative, and negative to make it more accurate. This is the proposed flowchart of the model. Input data set, preprocessing, tokenize,
Sorry,
calculate.
I'm interrupting you.
Yes, ma'am.
You have only 2 minutes. Can you please
Okay.
continue?
Yeah, I'm almost done. So this is the result that is obtained by using Vadder tool. So here we can see, which is not quite same as the graph which we had seen earlier. And here, okay, I'll just conclude. The models here are taken mainly from the most recent fuzzy logic papers. And it is mainly used to analyze text with ambiguous or polarized in meanings or different sarcastic texts. Now we are planning to improve our model by improvising our uh, proposed system for medical data analysis to assess the risk of patient. Here, this is why we are, the current work showed that the performance of the sentiment analysis containing the fuzzy sentiment is dependent on the word type, lexical, semantic, position of words, semantic, sentiment polarity, and several features. So this is the medical diagnostic system which has been kept in mind. So the previous one, we can take the example from the previous graph and understand why we have followed this method. So we can assess the risk. So these are some references that have been followed. Thank you.
Thank you,
Okay.
dear author. Sir, I would request you to come up with some questions.
So does anyone has any question or professor, the chairman, so give some advice. Okay, so thank you, sir. Really?
Thank you, sir. Thank you.
Okay, so so it was very well. Okay, so I think we have due to time limit, so could you please pass to the next presenter?
Okay, sir. Thank you, dear author. Now, I would request our next author, Harshad, to present his PPT on the topic Unmask Mark's Face. Sir, are you there?
Yeah, I'm there. Just a sec. I'll just.
Okay, thank you, sir. You just can move forward with the presentation.
Yeah, just a sec.
The presenter, could you please follow the time limits for it's not over 15 minutes as well?
Is my screen visible?
Yes, sir, it is.
Okay, so the idea behind our research or the research that we have conducted is behind unmasking masked face. The flow about the presentation will be about the problem statement, literature survey, methodology, experimental results, conclusion, and future work. So the problem statement is about synthesizing unmasked images of the individuals through the adoption of the advanced technique called as the pix-to-pix generative adversarial networks. The big objective behind this problem statement is obtaining the intricate details that are hidden behind the masked or masked object or the object that is obscuring the image, the facial image. So to put it differently, the problem statement can be rephrased as removing the masked object from the facial image. The using millions of photographs. These methodologies or the prior methodologies replace the object area or the void area by similar patterns or patches, which cannot really be desirable at many situations. And these methodologies often lack realism and do not produce satisfactory realistic results. So GANs, generative adversarial networks, introduced by Ian Goodfellow and his colleagues, they involve two components, generator and the discriminator. So the main idea is to train the two components in an adversarial process where the generator is successful in producing the results that can outsmart the discriminator, when the role of the discriminator is to predict whether the sample is real or fake. Different variants of GANs have been put up in the recent times, like the conditional GANs. The main difference between a conditional GAN and the normal GAN model is that conditional GANs are based on a particular input that serves as a condition for the GAN to the output and result. Like the generator model produces results from noise, conditional GAN produces results from noise as well as the conditional input. Pix-to-pix GANs that are adopted in our methodology are a type of conditional GANs which are based on an input. The main idea behind adopting Pix-to-pix is not only because the conditional input, but also because of the loss functions that have been incurred in the Pix-to-pix GAN. It is trained based on two loss functions, that is the adversarial loss and the per pixel loss called the L1 loss. Okay, so the Pix-to-pix model are like the traditional or the typical GAN model consists of a generator as well as a discriminator. The generator model is made up of two components, the encoder component and the decoder component. It is important to note that both the components have equal number of layers or the equal number of blocks. The encoder section, it downsamples the images. So at each level or the each layer captures different low level as well as high level details, and the image keeps downsampling till the bottleneck layer. Whereas the decoder block or the decoder section upsamples the downsampled features. At the same time, what the main objective of the decoder block is to reconstruct the downsampled images, also using the information from the encoder block at the same level using something called as skip connections. So skip connections help transfer the information or the essential features from the encoder block to the decoder block so that the decoder block can reconstruct the image back to its original size and give out the essential features. Now, on the other hand, the discriminator model, the main objective is to determine whether the sample is real or artificial, or that is generated by generator model. The discriminator model can be based on different architectures, but the architecture that we have adopted is the patch GAN architecture. The idea behind patch GAN architecture is that smaller sections of the images are considered, and a likelihood of whether these sections being true or false, that is real or fake, can be determined. This likelihood serves as an input to the generator model so that the generator model can be trained on that likelihood. Essentially, to put it into different words, that likelihood pushes the generator model to generate even more realistic images that can outsmart the discriminator. This input is called the adversarial loss. So,
Sorry, sir, for interruption,
okay.
but I guess you are changing your slides, but it is not changing on our screen. Can you please fix it, or you are not changing the slide? Yeah, it has changed. Yes, sir, it has changed.
Okay, so can you just let me know on what slide you're on? It's like the discriminator model, right?
Yes, sir, it is architecture of the discriminator model.
Okay, so did I just miss out all the previous slides?
Yes, sir, because the slides were not changing.
You want me to do it again?
So you can ask the session chair. So
It's okay. We are listening.
Oh, okay. Okay, so I'll just do it here. Okay, so not just the adversarial loss, but the Pix-to-pix GAN is also trained using the L1 loss called the per pixel loss, which helps to determine the difference between the ground truth actual images as well as the synthesized images by the generator model. This is the training process flow, the fix-to-fix GAN. There is one common discriminator model, which is trained using two pairs. One pair will be the synthesized unmasked images with the input masked images, and the second pair will be the actual unmasked images with the input masked images. So the adversarial loss and the per pixel loss can be are derived, and the generator model is pushed to generate images that can outsmart the discriminator model, and the discriminator model gets better and better at determining whether the particular sample is real or fake. So when the proper equilibrium is achieved, we come to a conclusion that yes, the generator model can outsmart the discriminator now, and we have achieved somewhat realistic images. So these are the results that we have obtained after training our pix-to-pix GAN on the training data set. So we can clearly see that all some intricate features have been captured, the essential intricate features, and that those captured features are not so far away from the actual ones. But there does lack some amount of continuity in the synthesized images that will be a part of our future work. To determine the goodness or the likelihood of our results, we conducted a subjective analysis for 46 participants, and they did give us a very likely outcome. So they did like the output results that we obtained from the model. It is based on a particular formula, the likelihood index that we came across, and we achieved a 95.5 likelihood index. The future work will involve, although we did achieve good results, the big drawback will be, or the drawback I can say will be put up when this model is challenged against different types of masks. That will be a part of our future work, trying to make the model adapt to different types of masks, and enhancing the results as well as synthesizing results that seem even more realistic to the recipient. Yeah, so that was me.
Yeah, thank you for your presentation. What is
Yeah.
the outcome of your research?
So pix-to-pix GAN can be used for obtaining intricate details that have been obscured by objects in the images, not only for the translating images. If pix-to-pix GAN is held with a myth that it can translate images from one part to another part. So here we are saying that, yeah, it can obtain intricate details that have been hidden by some objects.
Thank you so much.
Thank you, sir.
Thank you, dear author.
Also, please pass to the next presenter. So I think we have to move back to the old one.
Yes, sir. Now it's a final call for author Tiwalade Udu to present her paper. Ma'am, are you there? Okay, moving to our last presenter, Deep Rohit. Sir, are you there?
Hello, ma'am. Can you listen me? Hello,
Yeah,
ma'am.
you are audible, sir.
Oh, thank you. I will present my screen.
Yes, sir.
Is my screen visible, ma'am?
Yeah, we saw that.
Oh, thank you, sir. So I am going to present on a potato leaf disease detection using convolutional neural network. This is the outline of my presentation. So first of all, introduction. Like in India, most of the most of the percentage of our people are dependent on agriculture, and at early stage finding of this disease will be very helpful in not only in India but also in other countries. Just like and CNN is find to be more efficient than other techniques for finding this disease. I have specifically taken a potato crop for my learning purpose and research purpose. The main disease contained by potato crop is early blight, late blight, and healthy leaves. So this is the papers I surveyed for before starting my before starting on convolutional neural network, like severity identification of potato late blight disease, detection of potato disease, detection for detection of potato disease, etc. From all this, I conclude that any paper doesn't give accuracy more than 97%, and they use methods like fluffy skimming, early detection, etc. But CNN gave me accuracy of 99.001% on the detection of potato disease. This is my methodology. First of all, data collection, then pre-processing data, then classification, and at last it comes evaluation. This is my data collection. Total, I consider 2,152 images, out of which 1,000 images were of early blight, 1,000 of late blight, and 152 for the healthy leaves. I converted into ratio of 80 to 20 training and testing set from the 2,152 images. My classification was based on input, convolutional layer, max polling layer, and fully connected layers. Convolutional input will be of type of image. Convolutional layer will extract the features of the image. Polling layer will set the volume of the images, and fully connected layer will be classified which disease is detected. My result and discussion, as you see. At last, I conclude that CNN gave me 99.01% of accuracy on potato leaf disease detection. And my future work, there is a limitation. It can be said that I have considered only one crop. It can be concluded for other crops too. These are my references. Thank you. So do you have any questions?
Okay, so please let me have some questions to ask you. So I'm not sure. So your model so can evaluate the input source like a video.
Means what, like it means output or something you want? Hello, sir.
So your research model so can analyze the input source, for example, video or only image.
No, sir. This is my. I have considered images as an input.
Just an image input.
Yes, image input as an image. Let me zoom in. Can you see? This is the afterwards means how classification will be done.
So how to protect when the leaves they have some problem to in the farms. So if you protocol is only recognize only image, so you have to collect some leaf in the farms to analyze. So I think this is not different from you can walk through the farms and diagnose it by themselves. Okay.
Sorry, sir. I didn't understand what you were saying. Please repeat. Hello, sir.
So I'm not sure. And so could you please show some how to implement for an application to the farmers?
Farmer with a ready-made application using convolutional neural network as a backend. The farmers will. Yes, sir. You were saying
This is
something.
only research state, right?
Sorry, sir.
This is only a research state, right?
Yeah.
This can be to the commercial products.
Yeah, it can be commercial product, but I have considered only one crop, and based on one crop, it cannot be commercialized. We need to consider more than one crops like potato, tomato, etc. for a commercial angle, because every farmer doesn't grow potato crop. They grow multiple crops, potato, tomato. It can be fruits like apple, etc. So the early detection of every crop is necessary.
Okay, thank you.
Thank you, sir.
Does anyone has any question? Oh, okay. So, dear professor.
No questions from my side. Thank you.
Thank you, sir.
Thank you, dear author. So I sincerely thank our authors for the excellent presentation contribution in this session and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this second version and the previous first conference. We will be happy to have you in the third version in 2024. All the presenters would be getting the digital certificates through email within 2 working days. All the papers have already awarded Springer live within 6 months. Kind of cooperate with the team of ISBM 2023. I also thank our session chairs, Professor Kankaran and Professor Prashant for chairing the session. A token of appreciation to the ISB 2023 and Global Knowledge Research Foundation and partners. I also request our session chair to enlighten me as well as our hardworking presenters with their beautiful words.
Yeah, all the presenters have presented their papers very well. The conference has organized very well, and the papers were from the different kind of countries and different people, and they have done a good job. And thank you for the kind invitation, and look forward for the future conferences. Thank you.
Okay,
Thank you
so
so much, sir.
here's our presentation and technical session. Yes. So my name is Kanakan Panipong. So I have to say thank you for having me to be a session chair here. Conference was very good, and so all presenter is work very hard to paid off for their papers to conference today. And thank you so much. And so we hope to see you in a next conference in next year. Thank you so much. And thank you, Asomya and Anisha. Thank you.
Thank you, sir.
Thank you so much, sir.
All the present as well as our session chair to kindly turn on the video camera so that I can take a quick snapshot.
Okay. Thank you so much. Thank you so much to all guys.
Thank you, Anisha. Thank you, Soumya. Thank you, everyone. Good luck.
Okay, good luck. See you next year.
Okay, thank you so much, everyone. Stay safe and take care.
Thank you, sir.
Thank you so much.